Example, discuss the solutions of the following system. Number first, x1 plus 3x2 minus 2x3 plus 5x4 is equal to 7. 2x1 plus 8x2 minus x3 plus 9x4 equals 9. 3x1 plus 5x2 minus 12x3 plus 17x4 is equal to 7. This one is basically a system of linear equations. The corresponding augmented matrix of the given system is this one. Clearly, the first column represents the coefficients of the variable x1. The second column represents the coefficients of the variable x2, 385, 385, and similarly third and fourth column are representing the coefficients of variable x3 and x4 respectively. On the right side of this vertical line, 4, 9, 7 are basically representing the constant terms of the given system. To get the solution, we have to transform this augmented matrix into echelon form. So, to start the row operations, first of all, we have to choose a pivot entry in the first row. So in the first row, the pivot entry is 1. A pivot entry is basically a non-zero entry from the left side. So from the left side, the non-zero entry in the first row is 1. So 1 is the pivot entry. And according to echelon form, the entries below the pivot entry must be 0. So to get zeros in place of 2 and 3, we have to eliminate them. By using two operations, we will subtract 2 times our first row from the second row to get 0 here, and similarly we will subtract 3 times our first row from the third row. So these are our desired operations. Now here basically we are subtracting 2 times of R1. So what is the 2 times of R1? 2 times of R1 will be 2 1s are 2, 2 3s are 6, 2 minus 2s are minus 4, 2 5s are 10, 2 4s are 8. Basically, we are subtracting these entries from second row, and in second row we have 2, so subtract this 2 from this 2. We will get 2 minus 2. Now subtract 6 from 8. We will get 8 minus 6. Subtract minus 4 from minus 1. We will get minus 1 plus 4. 10 from 9. We will get 9 minus 10. 8 from 9. We will get 9 minus 8. Similarly, in the third row, we are subtracting 3 times of R1. So 3 times of R1 will be 3 1s are 3, 3 3s are 9, 3 minus 2s are minus 6, 3 5s are 15, and 3 4s are 12. So subtract these entries from third row. We will get, subtract this 3 from 3, we will get 3 minus 3. Subtract this 9 from 5, we will get 5 minus 9. Minus 6 from minus 12, we will get minus 12 plus 6. 15 from 17, we will get 17 minus 15. 12 from 7, we will get 7 minus 12. Just simplify this matrix, we will get 1, 3 minus 2, 5 and 4 will remain same. 2 minus 2 will give us 0. 8 minus 6, 2 minus 4 plus, minus 1 plus 4, 3. 9 minus 10, minus 1. 9 minus 8, 1. 3 minus 3, 0. 5 minus 9, minus 4. Minus 12 plus 6, minus 6. 17 minus 5, 2. 7 minus 12, minus 5. Now, this one was the first pivot entry. Now, the second pivot entry is 2. So, now, according to echelon matrix, the entries below the pivot entry must be 0. So we have to eliminate minus 4 from this system. To eliminate this minus 4, we will add 2 times of second row in the third row. So the desired row operation is R3 plus 2 times R2. The first row will remain same, the second row will remain same, and 2 times of R2 is basically 2 times of R2 is basically 0. 2 times of R2. 2 2s are 4, 2 3s are 6, 2 minus 1s are minus 2, and 2 1s are 2. So here we are basically adding these entries in third row. So add these entries in the third row. We will get 0 plus 0, 4 with minus 4, we will get minus 4 plus 4, 6 with minus 6, we will get minus 6 plus 6, minus 2 with plus 2, we will get minus 2 plus 2, 2 with minus 5, we will get minus 5 plus 2. Just simplify this matrix, we will get 1 3 minus 2 5 0, and 0 2 3 minus 1 1, and the last row will become 0 0 0 0 minus 3. Now from the third row, as we know that this entry is basically the coefficient of x1, this one is the coefficient of x2, coefficient of x3, coefficient of x4. So this will give us 0 into x1 plus 0 into x2 plus 0 into x3 plus 0 into x4 is equal to minus 3, gives us 0 equals minus 3, which is not an acceptable result. So this shows that the given system, this one, is basically inconsistent. And if we look at the ranks, so the rank of complete matrix is 3. Why? All the 3 rows are non-zero rows, and this matrix is basically an augmented matrix, so the rank of augmented matrix is 3. Now look at this matrix. This one is basically the coefficient matrix of the given system, and its rank is 2. Why? In this portion just we have 2 non-zero rows. The third row is 0, so we eliminate them, and clearly 3 is greater than 2. This shows that when the rank of augmented matrix becomes greater than rank of coefficient matrix, then you will get no solution, and such a system will be an inconsistent system. Second part of example. Here we have also a system of linear equation, and its corresponding system is represented by AB, augmented matrix. In the same fashion, we have to transform the given system into echelon form, and the first non-zero entry from the left side in the first row is 1. So we have to eliminate 5 from the system, and for this purpose we will subtract 5 times our first row from the third row. So this one is our desired result. So just subtract 5 times of R1 from R3. We will get 5 minus 5 times of this one, 5 minus 5. And 5 times of this minus 2 gives us minus 10, and due to subtraction that minus 10 will become plus 10, so add 10 with 0. 5 times of this one is 5, and subtract that 5 from this minus 5, we will get minus 5 minus 5. 5 times of this 0 gives us 0, and subtract that 0 from 10, we will get 10 minus 0. Just simplify this matrix, we will get the first and second row will remain same. 5 minus 5 will give us 0, 0 plus 10 will give us 10, minus 5 will give us minus 10, and 10 minus 0 will give us 10. Now this one was the first pivot entry. Now the second pivot entry is 2, and now we have to eliminate 10, which is below the second pivot entry. So to eliminate 10, we will utilize a multiple of second row. So this one is our desired operation, R3 minus 5 times R2. The first and second row will remain same. Now just subtract 5 times of second row. So 5 times of 0 gives us 0, and subtract that 0 from 0, we will get 0 minus 0. 5 times of this 2 gives us 10, and subtract 10 from 10, we will get 10 minus 10. 5 times of this minus 8 gives us minus 40, and due to subtraction we will get 8 plus 40, and add that 40 with this minus 10, we will get minus 10 plus 40. Similarly, subtract 5 times of this 8. So 5 times of 8 gives us 40, and subtracted 40 from this 10, we will get 10 minus 40. Now just simplify the system. We will get 1 minus 2, 1, 0, 0, 2, minus 8, 8, and 0, 0, 30, minus 30. So for solution from third row we obtain, since we know that this one is the coefficient of x1, coefficient of x, coefficient of y, and coefficient of z. We get 0 into x plus 0 into y plus 30 into z is equal to minus 30. This gives us 30 equals minus 30. Divide both sides by 30, we will get z equals minus 1. From the second row we get 2y minus 8z is equal to 8. Substitute this value of z in this equation, we will get y equals 0. From first row we get x minus 2y plus z is equal to 0. Put the value of x and put the value of z and y in this equation, we obtained x equals 1. So the solution is clearly all the three columns are the pivot columns. This shows that all the variables are the basic variables. Also, the rank of this whole augmented matrix is 3. Why? Because all the three rows are the non-zero rows, and the rank of this coefficient matrix is also 3. This rank of augmented matrix is equal to rank of coefficient matrix is equal to 3. So from this we conclude that if the ranks of coefficient matrix and augmented matrix become same, and all the variables become basic variables, then the solution will be a unique solution and the system will be a consistent system.